are live now. Hello, everyone, and welcome to our This is Learning Community webinar. My name is Ahmed Mustafa, and I'm a senior full-stack developer and the co-organizer of This is Learning meetup. It's fantastic to see so many of you here today, here to learn and grow together. So today we have a special treat for you. Joining us as a speaker is someone who is not only deeply knowledgeable in the field, but also a key part of our This is Learning meetup. Please welcome Sonu. He's our co-organizer for our meetup. So Sonu will be sharing invaluable insights on boosting Angular application performance, a topic that is crucial to optimize the web applications. With this extensive experience in software development, we are in for an informative and engaging session. Before we dive in, a quick reminder: don't forget to follow us on Twitter using our handles on top of our screens, and the QR code for our website. This is the best way to stay updated for all our upcoming events. Also, if you have any questions during the webinar, please feel free to write them in the comments section. Sonu will address them as many as possible in the Q&A session afterwards. So thank you all for being here. Without further ado, so let's get started.
Hey, thank you, Ahmed. How are you doing today?
Good, everything's good. So
Perfect.
the stage is yours. You can start now.
Okay, thank you. So my name is Sonu Kapoor. As Ahmed mentioned, I'm also one of the co-hosts of This is Tech Talks. I've another Angular podcast that I'm running, Angular Catch Up. If you want to check that out, as always, you can connect with me on LinkedIn or GitHub. So in today's presentation, I will be speaking about performance tips for Angular. I'll touch base on the following topics: lazy loading using routes, deferred views, optimized images, CDNs, signals and observables, and change detections, and zoneless. So let's get started with lazy loading. Lazy loading is essentially a design pattern commonly used to defer initialization of something until it is needed. So in Angular, lazy loading helps to load feature modules or standalone components only when, like I said, when they need it, rather than loading everything at once during the initial load. And the benefits are that it can significantly reduce the bundle size and the load time, which improves the application performance. Angular will automatically create smaller chunks of JavaScript files. It enhances the user experience by loading then only the important resources, which also helps in optimizing resource usage and memory management. Angular has built-in support for that from the early days on, and you can easily set up the modules or components to lazy load using the router configuration. You can also create custom preloading strategies to control which modules should be preloaded based on certain conditions. So imagine having a route configuration with 10 components that are equally loaded. You would have something like this. If I build my Angular application using ng-build, this is what you would get. You get 3 chunk files, and the main chunk is the one that we want to reduce the size on, right? So right now the size of the main bundle is relatively small because of a small project. But if you have a bigger project with a ton of components, you can see this could easily get out of hand. So to lazy load standalone components, for example, all we have to do is change our routing configuration to use load component. If you're still using modules, you can use the load children callback instead. And this is how it would look. Now, if I add, for example, the same amount of components that I showed you in my previous example and lazy load them and build the application, then this is what we end up with. So you can see that my main bundle size has decreased by more than 50% by just changing the router configuration. And all I had to do was change my routing configuration to use load component or load children. So lazy loading is actually great and already well known. But what if I told you that there's another thing that you can do to increase your performance? And as previously mentioned, it's called preloading. So preloading is a feature that will load the components in the background without having the user to activate the route. So combining this with lazy loading your components or modules gives you the ultimate in performance and user experience. So this is particularly useful if you know that the user will be visiting a specific section of the site. Then you can preload those modules or those features. So in a module-based application, all you have to do is to set the preloading strategy property and set it to preload all modules. Okay, and for standalone applications, configure the preloading strategy by adding the with preloading to provide routers in the app config TS. Okay, so these are really cool features, or I guess quick enhancements you can do to lazy load your application. So the next topic that I will be talking about is deferred views. This feature allows components or parts of the template to indicate that they should be lazy loaded. So this works in conjunction with the intersection observer API, which will observe the component and render it as soon as it becomes part of the viewport. This can be very useful, again, for large applications or sections of an application that are not immediately visible or necessary when the user first lands on a page. And this works by adding the defer block into your template. It also comes with additional blocks such as placeholder, loading, error, and triggers. The syntax for using defer is straightforward and integrates seamlessly with Angular's existing template syntax. Here is an example of how it might be used. And when you build your application now, Angular will automatically create a lazy loaded bundle for this component. And when the component enters the viewport, Angular will fetch the bundle and render the component. You can see that here in the network tab, the highlighted chunk is loaded on demand. And so as mentioned earlier, deferred views comes with additional blocks. The placeholder is the first one I'll quickly discuss. So by default, the defer block will render the content when it is visible in the viewport. However, there can be delays. So for example, when the components are making HTTP requests. In those scenarios, we can use the placeholder option. Now be aware though that the content used for the placeholder is not lazy loaded. Okay, so the content in the placeholder is shown first until the defer block's contents are ready to render. The placeholder itself comes with an optional argument called minimum. This allows you to set the time to display the content. And here is how this would look. So while the images are loading, you would see loading images. Now here you could also use a spinner or something else, an animated GIF that would appear while the image is still loading. Next is the loading block, which is used to display some content while the content defined in the defer block is still loading or has started to load. So this is different from the placeholder block, which will appear before the loading starts. This block comes with two optional arguments, after and minimum. So similar to the placeholder argument, the minimum argument is used to set the time to display the content. The second argument, after, is used to define the waiting time before showing the loading content. So here, for example, we're telling the block to wait at least 1 second before displaying the loading content and show it for at least 500 milliseconds. So this is a technique used to avoid any flickering that could appear because the content is very quickly loaded. And then there is the error block. So this error block can be used when the deferred loading fails. Again, similar to the placeholder and loading blocks, the content inside that block is not lazy loaded. So coming to our triggers now, which can be quite useful if you want to use fine-grained control on when the content should appear. These are triggered using when or on. Here's an example. So here we say load the images when some condition is truthy. Keep in mind though that when the condition becomes falsy, then the placeholder will not appear. So it's a one-way interaction. Similarly, you can use the on trigger. So in the second example, we're using two on conditions. These conditions are executed always with or. So it's not an and, it's always an or condition. You can also mix when and on conditions. And these are also always or conditions. So in this example, I'm saying trigger the block if the user interacts with the placeholder or after 5 seconds. And that's wraps it up for the deferred views. Coming next is our ng optimized directive. So this directive is probably one of the most underused directives to optimize performance and images. And actually comes loaded with many out-of-box features. In this section, I'll cover a few of them. So unlike the standard image element, the directive can automatically handle image resizing through the source set attribute. This ensures that users always receive the most optimized version of an image of their device and network conditions. Imagine having to set the source set manually to support all the image sizes. Here's the list of source sets if you're wondering. And if you had to write this list manually, it would look something like this. So this isn't even the complete list yet. It depends on the images that you are supporting, or the size of the images, sorry, that you are supporting. Having the directive take care of this all for your images can be a huge time saver. Using the lazy attribute can leverage the technique to defer the loading of off-screen images until they're needed. So this is the same technique as we saw earlier with the defer block. This reduces the initial load time and improves the perceived performance of your application. And all you have to do is add the loading attribute and set it to lazy. So now this sounds awesome, and you should only use this though for images that are not in the viewport. Okay. So if you're using images on the first page load in the first viewport, then you want to eager load those images. So for example, your company logo or something in the header, you always want to eager load them. So this is very important as you want to show your images as soon as possible. By default, lazy is set to all images that are not marked as priority. So be careful with that. Another great feature of the directive is the placeholder. So this attribute helps to manage how a placeholder can be used while the image is loading or being fetched. This, on its own, provides a much better user experience. If you're using a CDN like Cloud Binary that supports image resizing, you should automatically receive a low-resolution image for the placeholder, and you don't need to set any value for the placeholder attribute. But if you want to use a completely different image, then you can also set the placeholder to an encoded version of the image in base64 format. So here, I'm using a simple base64 for the placeholder. You'll notice that the image on the left is quite blurry. So this is actually on purpose. It gives a nice user impression that the final image is still being loaded. You can, however, disable this effect if you do not want to use it. As seen on the right, using the placeholder config object and setting the blur property to false. So let's talk about responsive images. So the directive supports responsive images out of the box. It will automatically set the source and attribute that we saw earlier with the necessary information, giving the browser instructions to download the best possible image based on the user's device. So this can work with or without the size attribute. The directive will automatically generate the density-dependent source set, and it can also auto-resize the images as you resize your browser. So let's see an example that uses media queries to control image sizes. So a very common approach is to render multiple columns on the desktop while rendering a single column on the mobile. Here, the directive will use 100 view width as a factor to download the image on viewport with maximum 768 pixels, and otherwise it will use 50 view width. So what that means is that when two columns are displayed, then the image will be smaller because you have a smaller viewport. And when it's a single column, you'll actually get a larger image. So that means that the directive will download the respective image for the given size. So setting the sizes with the media queries can be quite helpful. And you can see as I resize the screen in the network tab, how the second image is downloaded. Okay, so that's a wrap for the directive. Next, we will touch base on the content delivery network. So let's start with understanding what a content delivery network, CDN, really is. So while this is not directly related to Angular, it is very important for web applications, and it's good to have some understanding of it. So essentially, a CDN is a network of servers that are strategically placed around the globe. So the idea is to have copies of your content, like images, scripts, style sheets, and even videos stored on these servers. Now, when a user accesses your website, the CDN routes their request to the server that is geographically closest to them. So this process minimizes the distance data has to travel, which again reduces the latency and speeds up load times. So this results in a faster, smoother experience for the user. But beyond just speed, CDNs can also help manage traffic more effectively, reducing the load on your origin server and again improving your website's overall performance. Now let's dive deeper into CDNs, how CDNs can directly improve your website's performance. Again, first, as mentioned earlier, CDNs reduce latency by serving content from servers that are closer to the user. So that means data travels less, right? Has less distance to travel. And CDNs play a critical role in that, especially in load balancing. By distributing incoming traffic across multiple servers, They prevent any single server from being overloaded, ensuring consistent performance even during traffic spikes. Another key advantage is the optimized content delivery. Many CDNs offer features like content compression, image optimization, and adaptive bitrate streaming for videos. Image optimization, for example, is very important if you're working with the ng optimize directive, because in the directive you can actually set an image provider, and the directive then will automatically use that provider as your base for all of your images. So it's very important when you're using the directive. So these features ensure that your content is not just delivered faster, but also optimized for the user's device and the connection speed. And lastly, CDN also enhances your website security. So they can mitigate DDoS attacks by absorbing malicious traffic and provide SSL or TLS encryption to secure user data, which is becoming increasingly important in today's digital landscape. So with a CDN, you're not only boosting performance, but you're also adding a layer of protection for your users. Our next quick topic is on signals. So let's first explore how signals can enhance performance in Angular applications. So one of the key benefits of using signals is their efficient change detection mechanism. Unlike traditional methods, where Angular might check an entire component tree for changes, signals track state changes precisely. So that means that only the part of the UI that needs updating are re-rendered, significantly, reducing unnecessary re-renders and again boosting the performance. Another big advantage is simplified state management. With signals, you can directly react to state changes, cutting down the complexity in the component lifecycle. This reduces the overhead associated with managing state across your applications, leading to better performance. Finally, because signals only trigger updates when absolutely necessary, the overall rendering process becomes more efficient. Your components render faster, and the user experience improves. Signals are a powerful tool for creating more performant Angular applications by minimizing the work done during change detection and rendering. Sorry about that. So let's quickly talk about observables and how they contribute to performance improvements in Angular. So first, observables excel in handling asynchronous data, which means your application can update the UI without blocking the main thread. So this is very important for tasks like HTTP requests, user inputs, or real-time data streams, where you need the UI to remain responsive while waiting for the data. Another key performance to boost comes from lazy loading data with observables. You can set up observables to load data when it's actually needed, reducing the initial load time of your application. So this approach ensures that your app remains fast and responsive, even as it scales. And lastly, observables allow for optimized data streams through the use of RxJS operators. You can filter out, for example, unnecessary data, debounce user inputs to avoid excessive processing, and even throttle events to manage the flow of data efficiently. By minimizing unnecessary processing, observables help keep your application running smoothly even under heavy load. So, in summary, observables enhance performance by efficiently managing asynchronous operations, enabling lazy loading and optimizing data streams to ensure your Angular application remains fast and responsive. Coming to change detection now. So change detection is one of the core mechanisms in Angular that tracks changes in your application and updates the UI accordingly. By default, Angular uses a strategy that checks the entire component tree for changes, which ensures that everything stays in sync, but can be performance intensive, especially in very large applications. To optimize this process, Angular offers the on-push change detection strategy. This strategy only checks a component and its children when one of its input properties changes. And as a result, this reduces the number of times Angular needs to re-render components, which will boost your performance, especially in complex applications. By using on-push, you can skip unnecessary checks and focus on only what matters, those components that actually need to be updated. And this makes your application faster, more efficient, and able to handle more complex UIs without any performance degradation. Now let's dive into the concept of going zoneless in Angular, a more advanced approach to improving performance. So Angular typically relies on a library code called Zone.js to automatically trigger change detection whenever something in your application changes. So while this makes development easier, it can also lead to over-triggering of change detection, causing performance issues, especially, like I said earlier, in larger applications where changes are frequent. So zoneless architecture removes this automatic triggering. It gives you manual control over when change detection runs. By explicitly controlling these triggers, you can avoid unnecessary checks and re-renders, leading to a much more efficient application. So the performance benefits of going zoneless are very noticeable in large-scale applications. You reduce the overhead associated with constant change detection, resulting in a much more predictable and optimized performance. This approach requires a deeper understanding of your application state management, but can also lead to significant performance gains when implemented correctly. So, before you start implementing this, keep in mind that this API is currently experimental, so anything can change at any time. So regardless of that, here's a snippet of how you could try this out. And again, if you run into any issues, feel free to open a ticket in the GitHub Angular repo so that the Angular team is aware of it. And that's it. I hope these tips were helpful. And as always, please connect with me over LinkedIn and Twitter. Thank you.
So thank you very much, Sonu. I think we don't have any questions for us. So yeah, thank you very much for sharing your expertise on how to boost our Angular applications. It was an incredible insight session. I'm sure everybody gained a lot of valuable knowledge today. So to all of our attendees, thank you very much for joining us and for participating. We hope you found this session enlightening. And if you still have any questions, just send us on our Twitter accounts. We can answer directly there. By scanning the QR code, you can check our website for our next events. And yeah, remember, the learning doesn't stop here. Our community is all about continuous growth and knowledge sharing. So stay connected and yeah, waiting for you in the next session. Have a great day, everybody, and thank you.